We're going to be solving absolute value inequalities. So this is like absolute value equations. For the first case, case 1, since the absolute value bars are isolated, we're going to set this equal less than 9. Keep it positive. Case 1 is positive. This is the given information without the absolute value bars. Case 2 would be, I'll write it here so you can see it better. Case 2 would be flipping the inequality sign to greater than and changing the 9 to -9. Add 12 to both sides. 3p is less than 21. Divide by 3 on both sides, and p is less than 7. And then add 12 to both sides here. 3p is greater than 3. Divide by 3 on both sides. P is greater than 1. And then go to the original inequality symbol. In this case, it was a less than. I've said this when we were learning compound inequalities. I said that it would always be less than as our way to remember. This is an and. And so the way we write our ands, we start with the smallest number, then we use a less than or equal to symbol, x, in this case p, less than big number. So my smallest number is 1. It's a less than, not less than or equal to, x less than 7. In set builder notation, this is for all values of x such that 1 is less than x is less than 7. And on a graph, put 1 and 7, open circles, and it's an intersection. An intersection where it's going in between the two. And you can check that because if you flip this part, x is greater than 1, keep this part the same, x is less than 7, well, greater than 1 is going to the right, less than 7 is going to the left, and so they're meeting as an intersection. Here we need to isolate the absolute value bars first. Now we can write our two cases. X is less than 12, where we keep it as the given, and then x is flip the inequality sign, change the 12 to -12. And now we can solve both, but it's already solved. So on a graph, we have -12 and then 12. Put 0 in the middle if we want. And we go back to the original symbol, which is the less than. So this is going to be an and. So I have to write this as a compound inequality. Small number less than x less than big number. Right? In set builder notation, I could put the bar in front and the braces. And then as a graph, open circles at 12 and -12. And this is an intersection. Okay, for example 2, the difference now is that this is greater. I call it greater. Oops. Greater. It's an or, greater than. Okay, so it's going to be, we write our first original given problem without the absolute value bars, and then we flip the inequality sign and change to a negative. Add 5 to both sides. X is greater than 9, and x is less than 1. Here's the graph and the set builder notation for that.